Welcome to my 36th tutoring session in A-level chemistry. In this video, I'll give a detailed explanation about the principles one should be familiar with in order to understand the arrangement of electrons in atoms. Don't forget to subscribe my channel, share, like, comment and watch the full video. Here's the overview of my presentation. I'll give a detailed explanation about Pauli's exclusion principle, Hund's rule of maximum multiplicity, and Aufbau principle with suitable examples. This will be followed by practice problems. And finally, I'll end the session with summary. So one should be familiar with these three basic principles in order to understand the arrangement or distribution of electrons around the nucleus of an atom. So what does the Pauli's exclusion principle say? It says that no more than 2 electrons can occupy the same orbital and they must have opposite spins. So the orbital is symbolically represented by oval and electron by arrow. So the oval represents the orbital and the arrow represents electron. So one arrow is equal to 1 electron while 2 arrow represents 2 electrons. So what you see here is 2 electrons with opposite spins in an s orbital. Now electron is a negatively charged subatomic particle. It has a natural property called spin and it spins either in the clockwise direction or anti-clockwise direction. If the negatively charged electron, if it spins in the clockwise direction, it will have a spin value of half and is denoted by up arrow. And if the electron spins in the anti-clockwise direction, it will have a spin value of minus half and is denoted by down arrow. So the spin of the electron can be denoted by the arrow pointing up or down, that is up and down arrows. So always remember the first electron occupying the orbital will have a spin value of plus half and this will be followed by the second electron with a spin value of minus half. So always the first electron occupying the orbital will have spin value of plus half. So if the electron is spinning in the anti-clockwise direction, it will have a spin value of minus half and is denoted by down arrow. And if the electron is spinning in the clockwise direction, it will have a spin value of plus half and is denoted by up arrow. So what does the Hund's rule of maximum multiplicity say? It states that electrons will occupy separate orbitals with parallel spins before pairing up. So let me explain with respect to the oxygen atom. Atomic number of oxygen is 8. So there will be 8 protons in the nucleus of oxygen atom and there will be 8 electrons around the nucleus of the oxygen atom in their respective shells or energy levels. So now the task at hand is to arrange or distribute the electrons around the nucleus of the oxygen atom. So the electronic configuration of oxygen will be 1s2, 2s2, 2p4. Remember, Hund's rule says that electrons will occupy separate orbitals with parallel spins before pairing up. And therefore, the electronic configuration of oxygen will be 1s2, 2s2, 2px2, 2py1, 2pz1. So you should be very careful when you are filling the p orbitals because p orbitals are degenerate orbitals of the same energy level. And therefore, the 2p sublevel in oxygen is filled as follows: 1s2, 2s2, 2px2, 2py1, 2pz1. So 1s2. So this is the orbital diagram for oxygen atom. 1s2, 2s2, 2px2, 2py1, 2pz1. So you should be very careful when you are adding electrons to the degenerate orbitals. So the order of filling will be: now first you add 1 electron each to the degenerate p orbitals, that is having a spin value of plus half denoted by up arrow, and then you start pairing it. So first you add 1 electron each to the p orbitals and then you start pairing it. So this is the correct order of filling the orbitals with electrons. So Hund's rule says that electrons will occupy separate orbitals with parallel spins before pairing up. And moving on to the Aufbau principle. Now Aufbau principle states that electrons first fill the lower energy orbitals before occupying the higher energy orbitals. So let me explain this particular principle. So we got the nucleus of a particular atom, and the electrons will first fill the low energy orbitals before occupying the high energy orbitals. So 1s2 will be the 1s orbital will be the lowest energy orbital. This will be followed by the next high energy orbital 2s, 2p orbital, 3s orbital, 3p orbital, 4s orbital, 3d, 4p, and 5s orbital. So the order of filling of the orbitals with electrons will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and 5s2. So this is the order of filling. So as per the Aufbau principle, electrons first fill the lower energy orbitals before occupying the higher energy orbitals. And 1s orbital will be the lowest energy orbital or the lower energy orbital, and it is very close to the nucleus, and therefore it experiences a very strong attractive force towards the positively charged protons present in the nucleus of the particular atom. And here in this case, the 5s orbital will be higher energy orbital because it is far away from the nucleus, and it experiences very weak attractive force towards the positively charged protons of the nucleus. Now, before I take up some practice problems, so I would like my viewers to know about this particular golden rule. That is, the first electron occupying an orbital will always have a spin of plus half, and this will be followed by the second electron with a spin value of minus half. So always the orbital will be occupied by the electron having a spin value of plus half. This is denoted by up arrow, and this will be followed by second electron occupying the orbital, and this will be having a spin value of minus half, denoted by down arrow. Now time for the practice problems. An electronic configuration of boron is 1s2, 2s2, 2px1. Now, what is the atomic number of boron? Atomic number of boron is 5, which means it has 5 protons in its nucleus, and there has to be 5 electrons around the nucleus of the boron atom in their respective shells or energy levels. So now the task at hand is to arrange or distribute these 5 electrons around the nucleus of the boron atom, taking into consideration or considering all the 3 basic principles, that is Pauli's exclusion principle, Hund's rule of maximum multiplicity, and Aufbau principle. So what does the Aufbau principle say? It says that electrons first fill the lower energy orbitals before occupying the higher energy orbitals. So the Aufbau principle is satisfied. And what about the Pauli's exclusion principle? It says that no more than 2 electrons should occupy the same orbital, and it should be of opposite spin. Yes, we see no more than 2 electrons in each orbital. So we abide by the Pauli's principle. And there's one principle left over, that is the Hund's rule of maximum multiplicity. So what does the Hund's rule say? It says that electrons occupy separate orbitals, degenerate orbitals, with parallel spins before pairing up. So here we see only one electron in the 2p orbital, 2p, that is 2px orbital, while the 2py and 2pz orbitals are empty, as boron has only 5 electrons in its valence shell. Moving on to the carbon atom, atomic number is 6, the total number of protons is 6, the nucleus of carbon atom, and there has to be total of 6 electrons around the nucleus of carbon atom. So now the task at hand is to arrange or distribute the 6 electrons around the nucleus of carbon atom. So Aufbau principle, electrons first fill the low energy orbitals before occupying the high energy orbitals. And Pauli's principle, no more than 2 electrons must occupy the same orbital and should be of opposite spin. And what about the Hund's rule? It says that electrons occupy separate degenerate orbitals. So Hund's rule is applicable only to degenerate orbitals. So here the degenerate orbital is p orbital. The meaning of degenerate orbital is the orbitals having the same energy or that lie in the same energy level. So here we see that electrons occupy the separate p orbitals before pairing up. So there are only 2 electrons in the p subshell. So electronic configuration will be 1s2, 2s2, 2px1, 2py1, 2p z orbital is vacant or empty. And nitrogen, atomic number 7, there will be 7 electrons, 1s2, 2s2, 2p3. So Aufbau principle is satisfied. Pauli's exclusion principle is satisfied. And what about the Hund's law of maximum multiplicity? Yes. We see that electrons, now we can just focus on only the 2p orbitals, the degenerate orbitals. So here you find that electrons occupy separate orbitals with parallel spins. So it abides by the Hund's rule. An oxygen atom, atomic number 8, 8 electrons, 1s2, 2s2, 2p4. So both Pauli's exclusion principle and Hund's rule are satisfied. That is Aufbau principle is satisfied. What about the Hund's rule? So degenerate orbitals, the electrons occupied separate p orbitals before pairing up. Moving on to fluorine, atomic number 9, 9 protons in the nucleus, 9 electrons in their respective shells or energy levels. So Aufbau principle, electrons first fill the lower energy orbitals before filling the higher energy orbitals. And even the Pauli's exclusion principle is satisfied. No more than 2 electrons in each orbital with opposite spin. And remember, if there are 2 electrons in an orbital, they'll have opposite spins. And if there is only 1 electron in the orbital, it will be having a spin value of plus half. So always the orbital with only 1 electron will be spinning in the clockwise direction with a spin value of plus half and is denoted by up arrow. That is in the case when the orbital is occupied by only 1 electron. Neon, atomic number 10, 10 protons in the nucleus, 10 electrons will be in their respective shells or energy levels, 1s2, 2s2, 2px2, 2py2, 2pz2. So all the degenerate orbitals are completely filled with total of 6 electrons with 2 electrons in each degenerate p orbital. Sodium, atomic number 11, 11 protons in the nucleus, and we have to arrange 11 electrons in their respective shells or energy levels, 1s2, 2s2, 2p6, 3s1, and electrons are filled from low energy orbitals. Electrons first fill the low energy orbitals before occupying the high energy orbitals as per the Aufbau principle. And we see no more than 2 electrons occupying a particular orbital, satisfying the Pauli's exclusion principle, and even the Hund's rule of maximum multiplicity is also abided. So here's the shell diagram for the sodium. So you find 2 electrons present in the first shell, and these 2 electrons are present in the S subshell. And in the second energy level, second shell, you find 2 electrons present in the S subshell, 6 electrons present in the P subshell. And in third shell or energy level, you find 1 electron in the S subshell, while the P and D subshells are unfilled. They are vacant or empty. So overall the electronic configuration will be, so 1s2, 2 electrons in the S subshell of first energy level, 2 electrons in the S subshell of second energy level, 6 electrons in the P subshell of second energy level, and only 1 electron in the S subshell of third energy level. So overall the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. And finally, to summarize, Pauli's exclusion principle, Hund's rule of maximum multiplicity, and Aufbau principle, they provide a systematic approach to understanding the arrangement of electrons in atoms based on their energy levels, sublevels, orbitals, and spins. So in a nutshell, these three principles help explain the stability and organization of electronic configuration in atoms. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.